Isomerism. Once watch nomenclature videos, all videos. Okay. First one, structural isomerism. Structural isomerism. See, in structural isomerism, molecular formula is same, but differ in the bonding connectivity. Bonding connectivity is different. Okay, then that type of isomerism is called as structural isomerism. See, compounds having same molecular formula but different bonding connectivities. Are called as structural isomers. And the phenomenon is called as structural isomerism. And the phenomenon is common in every definition, so no need to write. Once look at this. Ethanol and dimethyl ether. In ethanol, oxygen is connected to how many carbons? One oxygen is connected to one carbon. Here oxygen is connected to two. Bonding connectivity. Connectivity is different or not? Here oxygen is connected to one carbon. Here oxygen is connected to two carbons. But formula is same. What is the molecular formula for this? What is the molecular formula? C2, two carbons. C2H6O. Here molecular formula is same. C2H6O. Same molecular formula but different bonding connectivities. These are called structural isomers. Okay. In stereo isomerism, can you give the definition in stereo? In stereo isomerism, same molecular formula, same bonding connectivity, but different spatial arrangements. Okay, we'll discuss stereo later. This is the definition of structural isomerism. Let us see types of structural isomerism. I'll send the copy. No need to write. Types. Chain isomerism. Just listen. Chain isomerism. Positional isomerism. Functional group isomerism. Metamerism. Tautomerism. And ring chain isomerism. This is small concept. Ring chain isomerism. Right, first one, chain isomerism. See, compounds having same molecular formula, but with a different number of carbons in main chain. Are called as chain isomers. See the definition: compounds having same molecular formula, but having different number of carbons. In main chain or parent chain are called as chain isomers. Okay. And phenomenon is called as chain isomerism. having different number of carbons in parent chain. See, when two compounds belongs to chain isomers, when they have different carbons in the main chain or parent chain. Look at this example. Normal butane, normal represented by N. In front of name, if you observe a small n, means this is normal without any branching, simple. N-butane. Once you tell me in this main chain how many carbons are present? 1, 2, 3, 4. 4 carbons are present. Okay. See this example. Give the numbering. In main chain, see, parent chain contains how many carbons? 3 carbons. Here parent chain contains 4 carbons. Molecular formula is say overall formula C4. Here also total how many carbons are there? C4 only. Molecular formula is same. But where is the difference? Differ in the number of carbons in the parent chain. If you observe the difference in the parent chain, that are chain isomers. Okay. So N-butane and this is, what is its name? Isobutane. N-butane, isobutane. Isobutane is the common name. Or 2-methylpropane. 2-methylpropane is the IUPAC name. 2-methylpropane, IUPAC name. Okay. Can you give another example? Important example. N-pentane, isopentane, neopentane comes under chain isomers. N-pentane, isopentane and neopentane. Second example. Normal pentane without any branching. N-pentane. This is N-pentane. Isopentane. Isopentane. Once count number of carbons. 1, 2, 3, 4 in the main chain. 1, 2, 3, 4, 5 in the main chain. And neopentane. Neopentane. Count number of carbons in the main chain. 1, 2, 3. 2,2-dimethylpropane. Its IUPAC name. Commonly it is called as neopentane. Its IUPAC name is 2-methylbutane. At second position, methyl group is there. This is methyl. So N-pentane, isopentane, neopentane comes under which type of isomerism? Chain isomerism. Okay. See, we have seen examples of open chain. Let us take some cyclic also. Okay, cyclic chain examples, cyclic compound examples. Can you tell me all these 3 belongs to chain isomerism or not? These A, B, C belongs to chain isomerism or not? What is the definition of chain isomerism? Compounds having same molecular formula but differ in the number of carbons in parent chain or main chain. In parent chain means in the ring how many carbons are present? 6. But formula is C6. 6 carbons are there. Here what is the formula? How many carbons are present? 6 carbons. C6. Here what is the formula? 4 in the ring, 5, 6. C6 only. So molecular formula is same. But what is the difference? Differ in the number of carbons in the parent chain. This is parent chain or parent chain or parent ring. Parent chain or parent ring. Parent chain or parent ring. Here 6 carbons are present. Here how many? 1, 2, 3, 4, 5 only. Here 1, 2, 3, 4 only. So chain isomers. Here parent chain is ring. Ring. Same formula but different carbons in the parent chain. So these 3 comes under chain isomers. This is about chain isomerism. Next, positional isomerism. Second type of positional isomerism. Positional. See, in positional isomerism, number of carbons in the parent chain is same. Number of carbons in the parent chain is same. Number of carbons do not changes. Like previous category. In the previous what happened? Number of carbons in the parent chain is changed. number is changed, right? But here number of carbons in the parent chain is same. See the definition: compounds with the same molecular formula but with differ in the position of functional group or substituent. Functional group or substituent are called as positional isomers. See the example: 2-chloropentane, 1 2 3 4 5, 3-chloropentane. These two belongs to which isomers? Positional isomers. Next example, second example. See, these are having same formula, but what is the difference? Differ in the position of functional group. 2-pentanone and 3-pentanone comes under positional isomers. Not only in the position of substituents, but we can take position of functional group also. Okay. One more example. What is its name? Orthoxylin and metaxylin. What is the relationship between them? Positional isomers. Orthoxylin and metaxylin, even paraxylin also. M-xylin. Okay, identifying positional isomeric relationship is easy if we get the structures, but if we get the name, okay, so that's why I'm giving some important names also. Next, what is its common name? Salicylic acid. Orthotolic acid and metataulic acid. Taulic acid. Benzene ring with COH and CH3 is taulic acid. Orthotaulic and metataulic acid. Waiting room never layer kada unnaru evaru. Right. Next, functional group isomerism. Third category, functional group isomerism. Functional group isomerism. Definition of functional group isomerism: compounds with the same molecular formula but with a different functional group. Compounds with the same molecular formula but with a different functional groups are called as functional isomers, and the phenomenon is called as functional isomerism. Okay, this is important. Chain isomerism, positional is very easy only. Okay, functional isomerism is important. Here we have some combinations. Okay, see, when alcohol is in combination with ether, then only check for functional isomerism. When carboxylic acid is in combination with ester, then only check for functional isomerism. First, the presence of combination is important. After, we will rectify whether that will show functional isomerism or not. For example, I am giving alcohol. Another 3 compounds are there. ether is there, carboxylic acid is there. I give an alcohol to you. With which functional group we have to compare, we have to check? Ether only. Alcohol and ethers only show functional isomeric relationship. Carboxylic acids and esters only will show functional isomeric relationship. Clear? When molecular formula is same, that is primary condition. Molecular formula should be same and the combination should be correct. Okay? Note down the combinations, means note down in the sense see the combinations. First combination, alcohol and ether. Ether formula ROR. Yes, aldehyde, ketone, enol. Unsaturated alcohols. Enols are called unsaturated alcohols. Third one, carboxylic acid and ester. Cyanide and isocyanide. Fifth category, primary, secondary, tertiary amines. Important. Primary, secondary, tertiary amines. Alkyl nitrites and nitroalkanes. ONO. Nitro, nitrite. Nitroalkane, alkyl nitrate. Both are ethanol and dimethyl ether. Dimethyl ether. Both are functional group isomers. Ethanol and dimethyl ether. One is alcohol, one is ether, and the molecular formula also satisfying. Right. First condition is both should have same molecular formula. What is molecular formula? C2H6O. Here what is the formula? C2H6O. Same molecular formula, but alcoholic functional group and ether functional group. Okay. Second example. What is second example? Aldehydes, ketones and enols. C. Propanol and propanone. Propanone, another name is acetone. Propanone, acetone and propanol. Both are functional group isomers, and enol also unsaturated alcohols. All these are functional group isomers. Next, carboxylic acids and esters. CH3, CH2, COOH. Propanoic acid. Form one ester with 3 carbons. How can we form? Ester formula is C double bond O. Ester. One carbon already came. Remaining how many carbons? One carbon is completed, right? One carbon is completed. Remaining how many? 2 carbons. Keep one carbon here and one carbon here. Over. First write C double bond O and write remaining carbons. Ester. Ester's nomenclature is very, very important. See, question won't come like this. Identify the relationship between these two structures. You won't get that structure. You will get the name. What is its IUPAC name? Don't look at that. What is its IUPAC name? See. That is importance of nomenclature. So watch the videos, everyone. Today I'll send the playlist. Ester's general format. Alkyl alkanoate. I explained clearly. This is alkyl part. Alkyl. I'll give one small information about nomenclature of esters. Once look at this. Let us consider this R as R dash. This is alkyl. What is alkyl? The group attached to oxygen is called alkyl group. Alkyl. Remaining part. Alkanoate. Alkyl. Format. Ester name will present in the following format. This format. First we have to write alkyl. Don't write substituent name also in esters. Generally in other functional groups we write substituent name first, but in esters we write alkyl part first instead of substituent. That is the specialty of ester. In others, carboxylic acids, alcohols, what we write first? We write substituent name, but in esters first we write alkyl part. What is alkyl part? How to identify alkyl part? Alkyl part is the part which is attached to oxygen. So take it as it easily. If CH3 is present, methyl. C2H5 is present, ethyl. Okay, alkyl, and this part is alkanoate. So first alkyl will come, after that alkanoate will come. Okay. Okay, look at this. CH3 is methyl. Methyl. Here how many carbons are there? 2 carbons. Ethanoate. Methyl ethanoate. Methyl ethanoate. What is the relationship between propanoic acid and methyl ethanoate? Functional isomers. Functional isomers. Can you draw the structure of methyl formate? Methyl formate. Which carboxylic acid is functionally isomeric with methyl formate? Methyl formate. Once look at this. This is methyl formate. Alkyl. Methyl. This part is alkanoate. How many carbons are present? 1 carbon only. Methanoate, or we can call it as formate also. Methyl methanoate or methyl formate. If 1 carbon is present, common name comes like this: formic acid, formaldehyde, formate. If 1 carbon is present, what is common name? Formic acid, formaldehyde, formate, formamide. Clear? You give the carboxylic acid name which is functionally isomeric with this. Here how many carbons are present? 2. Carboxylic acid with 2 functional groups, 2 carbons. Ethanoic acid, acetic acid, correct answer. Acetic acid is having how many carbons? 2 carbons. Okay. Acetic acid and methyl formate are functional isomers, correct only na? Statement type questions. Ethanoic acid, also called as acetic acid, both are functional group isomers. Right, next, 4th category, cyanides, isocyanides, methyl cyanide and the methyl isocyanide, CH3CN and CH3NC. Primary secondary amines, CH3 taken thrice N, CH3, CH2, NH, CH3, CH2, CH2, NH2. What is the relationship between these 3? Among these 3? Tertiary. Tertiary, secondary and primary. First of all, molecular formula is same or not? Molecular formula is same. That is basic condition. Primary, secondary, tertiary amines only, and molecular formula also same. So functional isomers. Relationship between primary, secondary, tertiary amines is functional isomerism when molecular formula is same. Another example. Its name is anisole, or also called as methoxybenzene. This is ether or not? Ether only, no? ROR. Anisole or methoxybenzene. This is cresol. These 2 common names are important. Cresol. Which cresol? O-cresol, orthocresol. Now you tell me the relationship between cresol and anisole. Functional group isomers. See, one simple trick. Its chemical properties different. Ether's chemical properties are different. Alcohol chemical properties are different. If 2 compounds chemical properties are different, then they are considered as functional group isomers. How can we know about different chemical properties? Different structures, different connectivities. For example, you tell me CH3, CH2OH. This is acid or nitrile? This is alcohol. This is. What about this? It's a chemical property. Its chemical property is same. This never become functional group isomers. If chemical properties of two compounds are same, then they are never considered as functional group isomers. If two compounds chemical properties are different, then we can consider them as functional group isomers. When two compounds will have different chemical properties, when their structures are different, when their connectivities are different. Here connectivity is same, OH, connectivity is same or not? Here connectivity is different, O carbon, O carbon only. These two are different compounds, different chemical properties. So functional group isomers. Can you frame another example? Can we write this in other format? Can we write like this? Benzyl alcohol. Correct, benzyl alcohol. So 1, 2, 3 comes under which isomerism? Functional group isomerism, functional group. Alcohol, phenol, ether. Last 8th I given under general consideration. One simple trick. Chemical properties different because this is alcohol or not. This is, you tell me this is phenol or not. Benzene is phenol. You tell me alcohol is having some different chemical properties, phenol is having some different chemical properties, and we know what about this ether. Ethers are having different chemical properties. If chemical properties are different, they consider as functional group isomers. Okay, right. Metamerism. Definition of metamerism.
Position of bivalent functional groups.
What is bivalent?
Valence is consonant.
Monovalent functional group and bivalent functional group. In any functional group, if two alkyl groups are present, like this is one alkyl, this is one alkyl, left hand side 1R, right hand side 1R is present, that is called bivalent functional group. Okay, ether, ketone also bivalent functional group. Yeah, ester also, see COO can be written as like this. Bivalent, two sides R groups are present, R and R, bivalent. Amide, CONH2, RCONH2. Can we consider amide? Secondary amine. R and R. Now you tell me monovalent. Sir, hello. అవును సార్ క్లాస్లో ఉన్నాను. సరే ఓకే సార్ రండి. All these are bivalent functional groups. కూర్చోవేసిన వస్తున్నాను. Monovalent means only one R group is present. One R group, not two R groups. All these are bivalent. Note down, bivalent. Monovalent functional group, alcohol. See, in alcohol, one side only R is present, monovalent. Like that, another functional group, aldehyde is monovalent. Even carboxylic acid also monovalent. One R group is present. Metamerism is shown by bivalent functional groups only. Monovalent functional groups do not show metamerism. Jibet, did you write the test? Write test. Organic. Didn't prepare. Tomorrow, because you know isomerism very well, so write test. No. Okay. Mention one point there. Only bivalent functional groups exhibit or show metamerism. Only bivalent functional groups show meta. Okay, coming to the definition of metamerism. Condition is over. Which functional groups exhibit metamerism? Condition is over. Coming to the definition. Its name is diethyl ether. Diethyl ether. Methyl propyl ether. Methyl propyl ether. Now see the definition. First of all, check left side how many carbon atoms are present. In the first structure, left side how many carbons are present? Two. Right side how many carbons are present? 2. Carbon number 2, here also carbon number 2. Left side, right side, same number of carbons are present. Now compare left side chain of first compound with left side chain of second compound. In this left hand side how many carbons are present? 1 only. Same or different? Different. Here right side 2, right side 3. Different or same? Different. That is only metamerism. Compounds having same molecular formula but differ in number of carbons in the side chains. In this side chain 2 carbons are there, in this side chain 1. In this side chain 2 carbons are there, in this side chain 3 carbons are there. Condition should be satisfied both sides. Okay. Difference should be present in the left, difference should be present in the right. Okay. Two sides, if number of carbons or structures are different, then they are said to be metamers. Compounds with the same molecular formula but differ in the not position, differ in the number of carbons in the side chains or structure of side chains. Differ in the number of carbons in the side chain or differ in the structure of side chain. So these two are metamers. Ethers will show metamerism. Why ethers will show metamerism? Because ethers are bivalent. Ketones will show metamerism. Why? Bivalent. Once look at this example. You tell me the relationship between these two. Which type of functional isomers these are? One, two, three, four, five. 1, 2, 3, 4, 5. What is the functional relationship between these two? Positional. Positional as well as metamers also. Positional because functional group is at third position. Positional because functional group at second position. Next, in the first structure, left hand side, how many carbons are present? 2. In the second structure, left hand side, how many carbons are present? 1 only. Here, how many carbons are present? Here, how many carbons are present? 3. So, positional as well as metamers also. Okay. ఒకసారి అవి పంపించాను అన్ని వీడియోస్ చూడు ఒకసారి ఓపెన్ చేయ గ్రూప్ సరే అదే వాట్సాప్ మొన్న నీకు జీవోసీనే కదా ఇచ్చింది మొన్న ఏం వాచ్ చేసావు నువ్వు ఎన్ని అయిపోయినాయి అవి థర్డ్ కంప్లీట్ ఇప్పుడు మొత్తం కంప్లీట్ చేసేసి మీ షెడ్యూల్ నాకు పెట్టావు కదా ఆల్రెడీ సరే ముందైతే అది కంప్లీట్ చేసాయి మీ మమ్మీ వాళ్ళు వస్తానన్నారా సరే ఓకే వస్తారు 8 o'clock 7:30 Next example. Give the relationship between these two. 1 and 2 are 1 and 2 are dash. 1 and 2 are functional group isomers. One is ether, one is alcohol functional group. 2 and 3, 2 and 3 are positional isomers. And 1 and 3, 1 and 3 functional only. 1 and 3 functional only. Functional. Because up to metamerism, one part means easy. Tautomerism onwards, concept is bit tougher. One more example. Give the relationship between all this. One and two. It's very easy with doubt. These two. Metamers. See, this is O. Consider this as the right side part. In right side, how many carbons are present? Methyl. Left side, how many carbons are present?
7.
1, 2, 3, 4, 5, 6 and 7. Here? No, here. Right side, how many carbons are present? Left side, how many carbons? 6. Difference is there. You consider like this, then you will understand easily. Like this. Okay? Here only na third position. Right side, how many carbons are present? 1. Left side, how many carbons are present? 7. Take this. Right side 2, left side 6. Difference is there. Difference is there in the number of carbons in side chains. So 1 and 2 are metamers. 2 carbons, 1 carbon. Yes, right side difference is there. Left side 6, here 7. Difference is there. Right side difference is there and left side also difference is there. So metamers. And 2 and 3? 2 and 3 metamers.
1 and 3 position.
Any other relationship?
1 and 3 position.
Positional. Metamers only.
1 and 3.
2 and 3. 2 and 3. 2 and 3 metamers only. 1 and 3? Positional. OCH3 same. That is important. But methyl position is at 1 to 3, at 1 to 4. So give the relation 1 and 2 metamers. 2 and 3 metamers. 1 and 3 positional isomers. Note down. 1 and 3 positional, 2 and 3 metamers, 1 and 2 also metamers. Only 1 and 3 are positional. Okay? 1 and 2, 2 and 3 are metamers. 1 and 3 positional isomers. That is up to you only. Okay? Analyze. Last part. Up to this very easy only. Concepts are tautomerism, keto, enol, tautomerism and time taking. Keto, enol, tautomerism. Compounds having compounds with the same molecular formula. Molecular formula is same, but differ in the
Place of hydrogen.
position of hydrogen. Different position of hydrogen are called as tautomers, and the phenomenon is called as tautomerism. We know resonance concept. Resonance. Shift this bond. Pi bond towards oxygen and H star towards oxygen. Then CH2 double bond C, OH star and the CH3. Both are having same formula but differ in the position of hydrogen. Here hydrogen is attached to carbon. Here hydrogen is attached to oxygen. Position in the hydrogen is different. Compounds with the same molecular formula but with differ in the position of hydrogen are called as tautomers. Tautomers, and the phenomenon is keto-enol tautomerism. So GI onwards will go slow, optical onwards will go slow. Structural you can manage, no issue. GI is bit tough and optical is also. First type of tautomerism, keto-enol. I kept directly heading keto-enol only. Nitro, SC nitro are there for JE means, but for NEET level we go with only keto-enol tautomerism. Keto-enol, nitro, SC nitro, imine, enamine, different tautomerisms are there, but keto-enol is important for NEET level. Keto-enol. Condition for keto-enol tautomerism. Presence of alpha hydrogen is the condition for tautomerism. See, basic question for NEET: in which of the following tautomerism takes place? Basic question. Alpha hydrogen should be present for keto-enol tautomerism. Okay, exceptional cases are there. In some ketones alpha hydrogen is present but they do not undergo tautomerism. Why alpha hydrogen should be present? Once see this last example. This is functional group. Which hydrogen we shifted? Tell me. Which hydrogen we shifted? Alpha hydrogen. If alpha hydrogen is not present, how can we shift? Shifting is not possible. Okay, that's why for keto-enol tautomerism alpha hydrogen should be present. How questions will come? Based on the names. You should have idea about names. Acetone. Imagine structure of acetone. Acetone. Will it show tautomerism?
Yes.
Acetophenone.
Yes.
Benzophenone. Cyclohexanone. So listen, watch nomenclature videos. Okay, I'll give names, important names here only, but you watch nomenclature. Start examples. See, these names are important for carbonyl compounds chapter also. Meeting off, na?
Waiting room.
See, one important question: how many of the following respond to Tollens test? Formaldehyde, benzaldehyde, propanol, propanone, like that. So these compound structures are important for other chapter also. Once focus on this formaldehyde. Can you draw structure of formaldehyde? HCH. Acetaldehyde. Propanone. Acetone. Same. Propanone, acetone, both are same. First you tell me, will formaldehyde gives or undergoes tautomerism? Why? No alpha carbon. Acetaldehyde. This is functional group. This is alpha carbon and alpha hydrogens are present, so it undergoes. Propanone or acetone? Yes, undergoes. Alpha hydrogens are there. 6 alpha hydrogens are there. And acetone, both are same only. This is also same structure, propanone, acetone. Acetophenone.
Yes.
Acetophenone. Yes. How?
This side 3 alpha.
Right side 3 alpha hydrogens are present. Alpha methyl group. Alpha methyl group. Alpha methyl group. What is the importance of presence of alpha methyl group? Ketones with alpha methyl undergo one important type of reaction, that is haloform test, iodoform test. So important for that iodoform test also. Condition is alpha methyl ketones only undergo haloform test. Right, these are simple examples. And can you try this? Benzophenone, will it undergo tautomerism? Benzophenone. Why?
Double bonded carbons.
This is alpha carbon. This dot represent alpha carbon. Alpha carbon. Where is hydrogen on it? And coming to exceptional, all these are very easy. Everyone can identify. See exceptional cases. Even though some compounds having alpha hydrogen do not undergo tautomerism, let us focus that. Exceptional cases, that cases only will come. Exception. You know this one, bridge compound. It can be written like this. Both are same. This and this both are same only. These two are same structures. This is called a bridge head. This is called as a bridge head. Means you have to imagine like this. It will come. This part will comes out like this, out of the plane. Bridge head, bridge head. Here these two are bridge heads. Imagine this part like this. Okay. See this. First locate alpha positions. Locate alpha positions. This is alpha position. This is also alpha position. Alpha position. At first alpha position, is there any hydrogen? No. This dot is already surrounded by 4 bonds, so there is no hydrogen. Okay. And what about second dot? Second dot is surrounded by how many bonds? 3 bonds. 1, 2, 3. 3 bonds. So can we imagine one more hydrogen?
Yes.
Yes. But one hydrogen is present, means alpha hydrogen is present, but that is present on the bridge head. This dot and this dot, these are called bridge heads. Bridge heads. Hydrogen which is present on the bridge head carbon do not undergo tautomerism. In this ketone, alpha hydrogen is present, but that alpha hydrogen is present on which carbon? Bridge head carbon. Very important exceptional case. It do not undergo tautomerism, even though it is having alpha hydrogen. Why? That alpha hydrogen is present on that bridge head. Example will come in this format or in this format. No need to worry. Okay. If we take this one, now
Yes.
see, this is bridge head, this is bridge head. But what about this? This is not bridge head. This star one, not bridge head. How many hydrogens it is having? 2 hydrogens. Yes, it undergoes tautomerism. When this position is blocked, means occupied by some other alkyl groups, then only do not undergo tautomerism. Okay. Okay. Important exceptional case. Cycloalkenes. Bridgehead. అక్షర కొంచెం అర్థం కానట్లు అనిపిస్తుంది ఎక్కడో ఒక దగ్గర. అర్థమైందా? ఇక్కడ నుంచి స్లోగానే పోతాం మనం చాలా. నెక్స్ట్ ఎక్సెప్షనల్ కేస్, లాస్ట్ వన్. Look at alpha position. This is alpha. This is alpha. How many hydrogens are present here? One hydrogen. One. Because this carbon is surrounded by how many bonds? 1, 2, 3. So we have to imagine one more hydrogen. One more hydrogen is present. Here also one hydrogen is present. What is the condition for tautomerism? Presence of alpha hydrogen. So will it undergo tautomerism? No. Because given under exception. Why? If alpha hydrogen, second exception, last exception is okay for everyone, bridgehead. Second exceptional case is if alpha hydrogen is present on double bonded carbon, it do not undergo tautomerism. Two exceptional cases. Alpha position is there, alpha hydrogen is there, but that alpha hydrogen is present on double bond. If alpha hydrogen is present on double bonded carbon, it do not undergo tautomerism. Hydrogen should not present on the double bonded carbon. Okay, right. For NEET level, another example is there.
Like 1P system, 1,5 system.
If I give that, confusion will arise. No, yes. But intentionally I am not giving because that is beyond NEET level. No need of that. In regular notes check I given already this. In our regular discussion, it will undergo, but that is in the general. For NEET level, basic questions only will come. Okay. This is about the introduction of keto-enol tautomerism. For NEET level, direct question, in which of the following tautomerism is present, in which of the following tautomerism is absent, these question only. Right? Complete isomerism, structural today. We'll start GI tomorrow, geometrical isomerism and optical.